As we covered in part 1 of this video, we want to insert a firewall between two EPGs, and we also want to migrate our default gateway from ACI to the firewall itself. In order to do this, we will first need to remove the existing Anycast gateway subnets from the bridge domains. So let's go back to our APIC and do that. If we now check the VM where we had left that thing running, we can immediately see that we lost communication as expected since the gateway is now gone. So we will now proceed to configure our service graph in order to reestablish communication through the firewall this time. First, you will need to perform the physical network configuration for your Layer 4 Layer 7 device following the golden questions as we learned in Module 2. Then, within our tenant, we will create a Layer 4 Layer 7 device representing our firewall service in this case. After that, we will create a service graph template, and finally, we will apply such template on top of a contract. You should be familiar with the step 1. Therefore, I will not be showing you how to do this configuration in this video, but feel free to review Module 2 if you need a refresher. Keep in mind that Layer 4 Layer 7 services are mostly physical or virtual when running on-prem. In our case, we will have a virtual ASA running on the same VMware VMM domain as our web and database VMs. We are using VMware's VDS integration. Therefore, I will not need to do anything else for step 1 in this case. If you're using AVE instead, keep in mind that although VXlan is extended to the host in such case, you will need to choose VXlan plus VLAN as part of your settings within your AVE VMM domain, and create a VLAN pool for Layer 4 Layer 7 service integration, since VXlan is not extended to such devices. Let's now take a quick look on vCenter to verify our ASAV configuration. As we mentioned, the firewall will be our gateway now. Therefore, the firewall admin has already configured the 1111/24 address for us using its gig00 interface, and the 2221/24 address, which is assigned to the gig01 interface, as you can see. A permit any access list allowing all IP traffic to traverse the firewall has also been configured. If we now take a look at our ASA VM settings, we can see that the network adapter 2 and 3, which correspond to gig00 and gig01 respectively, are not currently mapped to any specific port group. However, that will change automatically after we finish our service graph configuration. If we go back, our second step is to create our Layer 4 Layer 7 device. So let's go ahead and do it on APIC. First, we will go to our tenant, and in the Layer 4 Layer 7 section, we will click on Devices, and we will create a new Layer 4 Layer 7 device. We want the Managed option to remain unchecked, since we will be configuring this using Unmanaged mode, which means there will be no device package used. Then, we will add a name to our device, in our case ASAV, and we'll specify the service type we want to connect, which in our case is a firewall. Then, I'll indicate the device type, which in our case is virtual, meaning that we will have to select the VMM domain where our virtual firewall is running. In our case, this is the VMware VMM domain called MIA-VDS. As you can see, when using virtual Layer 4 Layer 7 devices, the default function will be go to or routed, which is exactly what we needed in this case. If you had a physical firewall instead, multiple implementation options would be displayed, including L1, L2, and go through. You may be confused initially when you see L2 and go through as different options in this case. However, the main difference is that when you choose L2 as option, you may use policy-based redirection for transparent Layer 4 Layer 7 services if you'd like. We will cover PBR later in this chapter. Let's go back and adjust the device type to virtual again, and then let's now add our firewall VM, which is also known as the concrete device. We may add multiple concrete devices or firewalls if you need, especially for high availability purposes. In our case, we just have one, so we will just add a name to it and select our ASAV VM from the list. Then, we will indicate that the interfaces we will use for our firewall service will be gig00, which is mapped to network adapter 2, and gig01, which is mapped to network adapter 3. Finally, we'll go into the logical device section to map our ASAV VM to our firewall service, which is also known as logical device. Our firewall logical device will have an outside interface, which will have our ASAV gig00 concrete device interface mapped to, and an inside interface which will be mapped to gig01. If you have multiple concrete devices, you can easily scale out your service by adding the corresponding concrete device interfaces to the logical device ones. In this case, it will be a one-to-one mapping, so we'll click OK and we'll be done. Our device has been onboarded, and you can verify or adjust your settings in the Devices section. It is now time to move to step 3, but before we do it, it is important to mention that you want to make sure your bridge domains are set to flood for both ARP and L2 unknown unicast when connecting layer 4 layer 7 devices such as your firewall. And this is because firewalls are usually silent hosts, and we need to learn their MAC and IP addresses as well, otherwise there won't be traffic forwarding. This is no issue if you're running the latest ACI versions, since ARP flooding is enabled by default in every bridge domain you create. But if you are running ACI 4.2 and earlier, just make sure you enable it and you should be fine. We will now create our service graph template as part of step 3, where we will simply drag and drop the logical device we created in step 2. We will specify it as routed in our case, and we could optionally set policy-based redirection here. But as we have mentioned before, in this scenario, we won't enable PBR since we will cover it later in this chapter. Done. Let's now configure the final step and apply our service graph template on top of a contract. If you remember, we have our ASAV VM with interfaces gig00 and gig01 already configured to behave as gateways for our web and database EPGs respectively. So let's apply our service graph template to our existing contract by performing a drag and drop on the L4-L7 icon and then selecting our template from step 3. Then we will simply match the corresponding bridge domains to each firewall service interface. In this case, the inside interface will map to the database bridge domain, and the outside interface will map to the web bridge domain. And we will be done. As you can now see, a layer 4 layer 7 icon appears on top of our contract. And if we go back to our VM's console, we can see that communication has been restored and traffic is now flowing through the firewall. Behind the scenes, ACI automatically performs several tasks for us, including an automated EPG to VM assignment, which can be easily verified by going back to vCenter and checking the ASAV network adapter groups. As you can see, the network adapters now have populated values which are different than the names we assigned to our web and database EPGs. This means that ACI automatically created a couple of shadow EPGs for each firewall interface association in order to preserve isolation from the actual workload EPGs and automating internal shadow contracts to make communication transparent between them. Let's go back to APIC and verify this actually happened. First, if we click on Deployed Graph Instances, we will be able to verify the settings of our service graph configuration. And then, if you click on the Function Node section, we can see that each shadow EPG got an automatically assigned VLAN ID from our VMM domain VLAN pool. We can confirm these are not the same web and database EPGs as the ones used by our web and database VMs by taking a look at the class ID or PC tag value displayed in each section, and then comparing it to the ones displayed in our web and database EPG. As you can see, the shadow web EPG has a PC tag value of 49156, and the actual web EPG has a 49155 value, which confirms that ACI automatically deployed a different EPG for our layer 4 layer 7 services. You can deploy up to 5 services in a service graph and chain them together, following the same logic we just covered. This may be useful if you want to insert firewalls, load balancers, and other services sequentially. We will learn how to configure service chaining and other scenarios in Chapter 2 of this module. After learning how to configure service graphs, you may be wondering, what do I lose if I choose not to integrate my L4-L7 services via service graphs and I do it manually instead? The main part is that you will be losing automating stitching services, which may be useful, especially as you scale. But you will also lose other interesting features that can only be deployed when using service graphs, such as PBR and copy services. With that being said, please join me in the final part of this chapter, where we will cover what is PBR, how it is configured, and a general overview of copy services and Cloud ACI L4-L7 services integration.